Imagine a land-speed record machine, but re-engineered for raw soil instead of flat salt beds. Imagine a mechanical leviathan designed for a single, brutal, and unyielding purpose to conquer the earth itself. Not by drilling through solid mountain rock, nor by carving out deep shipping canals, but by physically turning endless, sun-baked miles of rock, hard, baked clay soil into arable, highly fertile farmland, faster and deeper than any human engineering team had ever dared to dream. This is not just another piece of heavy agricultural machinery designed for routine field work. This is a monumental masterpiece of American industrial defiance, a one-of-a-kind, mechanical titan, and the official, undisputed holder of the Guinness World Record for the largest agricultural tractor on planet Earth. Enter the Big Bud 747. To truly comprehend the sheer scale of this machine, you have to leave behind everything you know about modern commercial farming. Standard tractors produced by massive industrial brands are engineered around global shipping standards, highway transport limits, and mass production assembly lines. They are designed to be practical, versatile, and easily haulable on flatbed trailers. The Big Bud 747 ignored every single one of those commercial constraints. Built in 1977 in the small, quiet town of Havre, Montana, by the Northern Manufacturing Company, this 50-ton steel behemoth was commissioned by the Rossi brothers, visionary cotton farmers operating out of Bakersfield, California. The Rossi brothers were facing an agricultural crisis. Their massive farming acreage featured extremely stubborn, compacted hardpan clay soil that stretched down several feet below the surface. Standard commercial tractors simply lacked the frame weight, the tire surface area, and the continuous rotational torque required to pull deep-ripping shanks through this concrete-like ground. When standard equipment attempted the job, their clutches burned out, their transmissions shattered, and their engine temperatures spiked into the red within hours. The Rossi brothers approached Northern Manufacturing with a single, seemingly impossible demand. Build us a tractor that can deep-rip thousands of acres of concrete-hard clay per day, without stopping, without breaking down, and without burning out its own drivetrain. The result was an industrial machine that permanently shattered every existing agricultural engineering limitation. It was built with unyielding, brute force over-engineering, created purely to become the fastest, most powerful land preparation vehicle ever conceived by human hands. When you stand next to this machine, looking up at its towering cab and colossal tires, you aren't just looking at a tractor, you are looking at a cathedral of raw torque and structural steel. Before we even examine the heart of this beast, we must understand the terrifying physics of soil resistance and structural stress. Plowing or tilling dry, compacted soil is not merely a matter of rolling heavy tires over dirt. When a deep ripper implement drops its hardened steel teeth 2 to 3 feet into the hardpan clay, the earth fights back with thousands of pounds of mechanical resistance per square inch. This force acts as a massive kinetic anchor, attempting to hold the tractor in place. If a tractor's frame is too light, the tires will simply spin uselessly on top of the soil, burning away expensive rubber while digging the machine into a deep grave. If the frame is heavy but structurally weak, the continuous twisting force, known as torsional shear stress, will physically warp the chassis frame, shearing bolts and snapping weld lines like dried twigs. To withstand these continuous, violent physical forces, Wilbur Hensler, the lead engineer behind the Big Bud, constructed a chassis that shared more in common with heavy mining dump trucks than any agricultural vehicle. The main frame rails of the Big Bud 747 were fabricated from solid 4-inch thick steel plate. Let that sink in for a moment. 4 solid inches of structural steel plate forming the main spine of the vehicle. This massive steel superstructure was continuously welded using industrial-grade techniques designed to flex just enough to absorb violent impact shocks while maintaining rigid structural integrity under extreme load. The overall length of the tractor stretched to over 27 feet, with a width exceeding 20 feet, and a height reaching over 14 feet to the top of the cab. This gave the Big Bud a massive, immovable footprint that provided an absolute foundation for transferring massive rotational power directly into the soil. Furthermore, the articulated steering joint connecting the front and rear frame sections had to be engineered to pivot smoothly while bearing up to 50 tons of total machine weight. Engineers utilized massive, heavy-duty hardened steel pins and giant spherical bearings usually reserved for multi-million-dollar open-pit mining loaders. This allowed the front and rear halves of the giant frame to oscillate independently up to 15 degrees, keeping all 8 colossal tires firmly planted on uneven terrain, regardless of ground contours. To move a 50-ton structural steel frame and drag multi-ton, deep-ripping shanks through compacted clay, standard high-horsepower agricultural engines were completely useless. A standard inline-6 or V8 diesel engine operating under continuous 100% load and high ambient temperatures would suffer catastrophic thermal failure, warping cylinder heads, melting piston crowns, or shattering internal wrist pins within minutes. The engineering team at Northern Manufacturing knew they had to abandon conventional agricultural engine options entirely. They turned to the high-stress, continuous-duty world of marine propulsion and heavy open-pit mining equipment, selecting the legendary Detroit Diesel V16 This engine is an absolute mechanical titan, a massive, 2-stroke V16 diesel power plant, displacing an astounding 24.1 liters, or 1,472 cubic inches of displacement. To put that figure into perspective, that is the total engine displacement of nearly 15 modern passenger cars, combined into a single, massive iron cylinder block. Because it operates on a 2-stroke diesel cycle, the Detroit Diesel V16 92T fires every single cylinder on every single downstroke of the crankshaft. This creates a continuous, uninterrupted delivery of power that generates unmatched low RPM rotational torque. But raw displacement alone was only the starting point. To achieve the terrifying power output demanded by the Rossi brothers, this massive V16 block was fitted with twin turbochargers and twin mechanical blowers, forcing immense volumes of pressurized air into all 16 cylinders with hydraulic-like force. Originally rated at 760 horsepower when it rolled out of the Havre assembly shop in 1977, later engine tuning, fuel pump calibration, and turbocharger upgrades pushed this mechanical monster to a staggering 1,100 horsepower. This massive horsepower rating is backed by thousands of Newton meters of earth-shaking rotational torque available right off idle speed. The mechanical sound of this 2-stroke V16 engine running at full throttle, all 16 massive pistons firing in continuous rapid succession while the twin turbos scream at maximum boost, creates a deep, resonant industrial howl that vibrates through the very ground under your feet for miles in every direction. It is the ultimate, unfiltered movement of the Iron Symphony, generating 1,100 horsepower from a 24-liter V16 engine is a magnificent engineering achievement. But in the brutal world of heavy land preparation, engine power is completely useless if you cannot transfer it to the ground without destroying the transmission. The mechanical path from the engine's flywheel to the wheel hubs is a brutal battleground of gear tooth stress, thermal buildup, and rotational shear. If you applied 1,100 horsepower directly to a standard manual or power shift agricultural transmission, the sheer twisting force would instantly strip the gear teeth clean off the shafts. To solve this dilemma, Northern Manufacturing integrated a heavy-duty Allison 6-speed automatic power shift transmission, sourced directly from heavy military and mining equipment. This massive transmission utilized a heavy-duty hydraulic torque converter that acted as a fluid cushion between the engine's violent V16 firing strokes and the mechanical gears. The torque converter allowed the engine to build up maximum boost pressure and torque before smoothly transferring fluid power to the heavy gear sets, eliminating destructive shock loads during gear changes or when the plow hit buried rock layers. From the Allison transmission, power was routed through heavy-duty drive shafts to custom-built planetary axle assemblies. These were not agricultural axles. They were massive Clark mining axles engineered to handle continuous torque multiplication at the wheel hubs. Planetary gear sets inside the outer wheel hubs reduced the rotational speed of the drive shafts while multiplying the final torque by several orders of magnitude right at the wheels. This meant that the drive shafts experienced far less twisting stress, while the wheel hubs delivered immense, ground-shredding force directly to the massive rim assemblies, transferring 1,100 horsepower and thousands of newton-meters of continuous, earth-shattering rotational torque from a massive 24.1-liter V16 engine directly into loose soil without destroying the land or spinning the wheels out requires an absolute masterclass in heavy chassis dynamics and tire contact physics. When a machine weighs over 50 tons and pushes close to 60 tons when fully loaded with its massive 3,780-liter fuel cell and heavy rear hitch assemblies, it faces a severe ecological and mechanical threat: soil compaction. If a heavy vehicle's total operating weight is concentrated onto a small surface area, the crushing downward force permanently destroys the microscopic pore structure of the subsoil. It turns deep agricultural soil into dense, airless hardpan, preventing root systems from expanding and stopping rainwater from absorbing into the aquifer. In essence, an improperly engineered 50-ton tractor would destroy the very land it was built to cultivate. To solve this massive physical dilemma, lead engineer Wilbur Hensler and the Northern manufacturing team equipped the Big Bud 747 with a heavy-duty 8-wheel drive configuration, running 4 colossal tires per axle in a dual-wheel setup. But standard off-the-shelf tractor tires available in the 1970s were completely inadequate. Under the continuous torque output of the Detroit Diesel V16, standard tire beads would slip on the steel wheel rims, or the sidewalls would physically tear apart under extreme rotational stress. Northern Manufacturing partnered directly with Titan tires to manufacture custom 8-foot-tall, 2.4-meter pneumatic tires specifically designed for the Big Bud 747. These custom tires featured massive, deep-cleated tread patterns and reinforced carcass plies capable of operating at reduced inflation pressures. This achieved a massive, wide contact footprint that distributed the 50-ton operating mass evenly across a vast surface area. By spreading the weight so broadly, the Big Bud actually exerted less ground pressure per square inch than many smaller, conventional farm tractors of its era, delivering unyielding, unbroken traction without crushing the underlying soil structure. Furthermore, managing the thermal energy generated during continuous high-power operation presented a brutal engineering challenge. Plowing thousands of acres meant the Big Bud's V16 engine operated under 100% continuous throttle load for 12 to 14 hours straight in scorching summer heat. At maximum fuel consumption, the thermal output produced by combustion inside 24 liters of cylinder volume is high enough to boil coolant and melt standard engine blocks within minutes. To maintain thermal stability, engineers integrated a massive industrial radiator footprint, paired with high-capacity external oil cooling loops for both the engine and the Allison transmission. The front radiator fan alone was a giant mechanical monster, consuming up to 50 horsepower just to pull hundreds of thousands of cubic feet of ambient air through the cooling fins every single minute. Fuel logistics were equally staggering. To keep the 16-cylinder beast fed during non-stop operational shifts, the Big Bud was built around a central, heavy-gauge steel fuel tank holding an incredible 3,780 liters, 1,000 gallons, of diesel fuel. Burning through hundreds of liters of fuel per hour, the Big Bud operated like a localized industrial refinery on wheels, a self-contained fortress engineered to survive the most hostile thermal environments on Earth. After decades of tearing through hard soil, changing ownership, and tilling millions of acres of farmland across California and Montana, the physical reality of maintaining a unique, one-of-a-kind, mechanical giant began to catch up with the Big Bud 747. By the late 2000s, the custom 8-foot Titan tires, which had performed flawlessly under extreme stress for over 30 years, finally reached the absolute end of their operational lifespan. Because Titan tires had long since decommissioned the custom manufacturing molds used to build those specific tire casings back in 1977, replacement rubber simply did not exist anywhere on planet Earth. The world's largest tractor faced an unprecedented crisis. It was mechanically sound. Its 1,100 horsepower V16 engine was ready to roar, but it was completely grounded due to a lack of usable tires. For over a decade, the legend sat silent. It was moved into museums and showcased at static agricultural exhibitions, leading transport enthusiasts and mechanical engineers around the world to believe that the operational era of the giant Big Bud 747 was permanently over. It seemed destined to spend the rest of its days as a quiet steel monument of a bygone era. However, true iron never dies. In 2020, Goodyear and Titan Tires collaborated with the Williams brothers, the tractor's current owners operating in Montana, to engineer a modern, state-of-the-art solution. They designed a custom set of massive Goodyear low sidewall, LSW, 1,400/30 R46 dual tires, mounted on specially fabricated heavy-duty steel rims. These modern, ultra-wide tires provided even greater flotation, reduced soil compaction even further, and were rated to absorb the full 1,100 horsepower torque load of the Detroit Diesel. In the summer of 2020, after years of silence, the key was turned, compressed air surged, and the massive 24.1-liter V16 engine roared back to life with a deafening industrial howl. The Big Bud 747 rolled out of the shop and returned directly to the open dirt fields of Montana, lowering its massive deep rippers into the earth once again. It proved to the world that even after 4 decades, no modern production tractor built today can match its sheer presence, raw power, and engineering dominance. Ultimately, the story of the Big Bud 747 is far more than a tale of agricultural machinery. It is a story of human ambition, engineering freedom, and mechanical defiance. It stands as living proof that when humanity faces the brutal limitations of nature and soil, we do not retreat. We design, construct, and conquer. It proved that without corporate restrictions, mass production shortcuts, or environmental compromises, engineers could build a machine powerful enough to tame an entire landscape. The Big Bud 747 is not just a commercial farming tool. It is a permanent monument to the golden age of heavy mechanical engineering. A 50-ton choir of twin turbochargers, 16 firing cylinders, and spinning rubber, singing its song of unyielding mechanical dominance across the Great Plains of America. It is the undisputed king of the field. It is the ultimate movement of the Iron Symphony. Thank you for listening to this extended episode of Iron Symphony. If you want to explore more extreme engineering, thermodynamic marvels, and legendary machines of steel, make sure to hit that subscribe button, like this video, and drop a comment below telling us which heavy monster we should dissect next. We will see you in the next Symphony of Iron.